Very good morning to students. Today we are going to learn blasting parameters, different firing procedures, charging around 3 slides. I am going to explain. My name is Karana Kumar, HOD Mining. Today topic is different parameters connected to the drill of blast holes. The prime objective of this topic is we are covering different parameters connected to blast. That is the patterns, charging, uh, how to drill blast hole pattern will be using in the different situations. So these are we are going to learn in this today class. Different patterns connecting to different patterns connecting to drilling of blast holes. The following are the major parameters related to the blast holes. Number one is a physical mechanical property of rocks is one of the comprising this factor for the selection of blast hole and type of the rock, dynamic tensile strength, compressive strength. So generally, these parameters will be getting in the rock specimen characters. When you collect the samples and test in the laboratory, depending upon the our uniaxial compressive strength mission, with different parameters you can identified by the different tests, including protodiagnostic index, tensile strength, compressive strength, the particular rock. So according to that one, you can be apply the which type of holes you are to make, whether the that small holes or big holes or depth wise, and using of the drill machine is also these parameters is depending. So the rock parameters is also rock physical mechanical properties also one of the important parameters for the blast hole design. And also the Young modulus. It is indirectly you can derive from the properties of rock, density and hardness of the rock, presence of discontinuity bedding planes. It is also one of the important factor because when presence of the bedding planes are weak in nature, in that case, particularly we not use the explosives because the explosives unnecessary filling with the loose material area. That maybe leads to other ground vibrations increasing, fly rocks and fragmentation, more dusty nature. So these will be encoding to the. So that is while geological study itself, presence of discontinuity the bedding planes also joints also you consider. So the geology of the area, particular watery nature or what are the geological parameters will also be prone into mind. Pit geometry is one of the important factor comprising the thickness of the coal seam or ore body and bench height. These also very how much depth is a hole will be supposed to be drilled is also one of the important factors depending on the bench height. So bench height is more, your drilling capacity is less than bench height. The further development will be affected. Overburden bench height, angle of bench slope, strip width, height to width ratio, and length of the width ratio also the important factors. Explosive characteristics, type of explosive, weight strength, velocity of detonation, powder factor, and loading density is also the important factors for the blast hole parameters for a design purpose. So type of explosive means whether you go to the site visit slurry or whether you go to the quadratus manner. Is full of the water in nature. We have to go to the anti water explosives are important. If in a dry kiln weather is different, and in iron ore mine is different, whole nature is different. So these are also. important parameters for the drill holes. And button also one of the factor. So drill hole the parameters also button is also one of the factor. The minimum distance from the face to the blast hole, this optimum button would be low range from the 20 to 25 times of the hole diameter. For example, the hole diameter is 300. How much button you are putting? 300 into 20 to 25 times. So this is one of the thumb rule for the calculations of the button. For 300 hole, the how much button is required means around 6 meters. Around 6 meters is button you are using in this case. If 200 button multiply the 200 into 20, that is a 4 meters we are using the button. So this is the one thumb rule for the diameter to uh, button. So simply logically 20 25 times of the uh, dia of the button is the dia of the hole is the simple methodology for that one. And spacing, the distance between adjacent holes in a row is termed as spacing. Spacing is generally considered to be 1 is to 1.5 times of the button. Spacing and buttons are the most important parameter drillings and are used to the calculate volume of the drilling block. Here is also we are using, for example, 300 diameter multiplied with 1.15. That is around 300 multiplied with 1.300 multiplied with 1.15 times. So this is a So the spacing is very less compared to the um, uh, button. Button is more spacing. You have to maintain the how much uh, 1 to 1 or 15 times of the spacing is more important. Then depth of the hole. In the depth of the blast hole, depending upon the machinery available for drilling and excavation, the output of the mine, the depth of the blast hole is generally in the range of 10 to 15 meters. When the huge draglines are employed, excavating burden drilling is carried out to depth 30 meters also. So this is the depending upon the our mechanization. If you use the manual mechanism, you go through for the depth is less. If you go to the for the dragline machine, with the depth of the bench, including all every parameter will be changing the as per the size of the equipment and others. So the initial planning is very essential according to these parameters is concerned. Now diameter of the drill hole. Blast hole diameter varies from the 0.5% to 2.5% of the bench height. The diameter can be calculated using the formula the d is equal to 25a, where d is the diameter, a is the bench height in meters. So let us take the one simple example. For the diameter is 300. We are applying, for example, 300 is a general universally using 300 diameter. So out what is the um, bench height? So multiplied with so 12 meters is the height of the bench for the 300 So like you can be calculated if the 25 multiplied with height is a 10. So 250 diameter can be suitable for the 10-meter bench height. So these are the thumb parameters for the initial understanding for the diameter purpose. The diameter also depending on the type of explosive, geology of the area, and size of fragmentation, is required. So diameter is depending on the type of explosive, geology, and size of the fragment. Whether they go to for the good fragmentation or go to the dimensional shape stone type, the blasting is different. The gender fragment is blasting is different. The diameter of the drill hole commonly adopted common adapter in open cast coal mines in India are 150 mm and 250 mm, and over 250 mm for overburden benches. Subgrade release is also generally carried out in an area of hard rock and within the incidences of the toil. The subgrade drill is generally ranging from the 10% to 12% of the bench height. If bench height is 10 meters, you go to the 11 meters. If the 20 meters, you go to the 12 meter, another 2 meters. Stemming. The purpose of stemming is to continue the high pressure gases that are released due to the blasting within the hole. The length of the stemming column is one third of the bench height and is not less than the burden. Coarse sand and other drill cutting are the most commonly used in stemming material. So generally, the where one third of the bench height is not less than the burden, you have to fill up with the stemming material. That means remain two third is the explosive. That is a within SMS or field. The remaining portion will be to what are the material drill core material come outside the hole that will be filled with and stabilizing the hole. Pattern of drill holes. The basic pattern of drill holes employed in open cast mines are square pattern is a popular one. Staggered triangular pattern is another one. Single row blasting and multi row blasting also another pattern. Wedge cut pattern is also you're using. Diagonal blasting pattern is also using. These are different patterns are using for the purpose of the open cast map for effective fragmentation and good directional falling of the material. Square patterns. This is pattern can also be called as a multi-row pattern. The drill holes are drilled in rows, one behind the other. The drill holes are drilled in rows, one behind the other. Uh, this is the square pattern. This is the you can observe the equal number of holes will be inside. For convenient purpose showing this one. Another figure is also very clear. This is a one four holes in the one side, another is four hole. Is a rectangular shape. The rectangular shape of drill holes. But firing is different. But the holes are prepared in the a specific manner of the patterns, like a square and a rectangular pattern. Right. Then staggered or triangular pattern. The drill holes are drilled in rows. The second row holes are not positioned mid of the in front row, first row of the holes. So such a way that you have to carry forward. This is the called a staggered pattern of drill hole. This is the example of the staggered pattern. Here you observe the one, two, three, four. First row is the rows, but the second is not exactly the parallel to the exactly coincident to the first row. It will be middle these two. These two. So similarly, next one is coming to this side and another is Milton. So such a way that this is called triangular pattern. This is called as a triangular pattern because the holes are will be connected with the triangle in shape. So this is the one of the parameter for the when cast away this material to this side instead of blasted and stable here. It will be falling to that step. You have blasted this one first and then this one, then this one, then by applying the delay. Such things, the pattern is also important while drilling. They take care of the not uniformly maintain the drill holes. Blast holes are pattern changing. When they are before the drilling only the their marking such a way that the blasting in charge will be blasted according to the design of the blast. So there is a special advantages than the regular patterns and also staggered pattern. So one more sketch I is showing here. Blast to drill in the staggered pattern. So mining services, textile resource collected. So you see that here the half of the material staggered from the main row. Then, however, considering the pattern of blasting, patterns can be classified as for following already above are the drill hole patterns. But the firing procedure is different. Whether square or rectangular or staggered pattern. Fire connection of firing is different. This is single row blasting, multi row blasting, wedge blasting, or diagonal blasting. The above two are the drill related patterns. Don't confuse of text. These are the patterns are different. These are the firing procedures. The connection of the holes, which hole first and which hole is next. So, single row blasting and multi row blasting. The single row means the one row first row is blasting is one technique. At a time blasting is another technique. Wedge blasting patterns is also another wedge shape, that is a V shape. Another is a diagonal type. So each one have its own advantages and applications depending upon the field applications, field requirement, nature of the bench, nature of our blasted material can be falling. So these will be the firing procedure can be going. That is the blasting procedure. That is the blasting pattern. So let us discuss one by one. First one is single row blast pattern. Single row blast pattern. The holes are drilled in a single row. The specific explosive consumption is low. The danger associated with the fly rock is more. So this is the one of the advantage and disadvantage of the single row blast pattern. Single holes are drilled in a single row. The specific explosive consumption is very low because of you are using a single row only. The danger is associated with fly rock is more. So the danger of the fly rocks is more in case of the single row blast patterns. So this is the one figure I am showing here. The single row blasting pattern, you can clearly understand here. This is the holes connected in one single wire, and then again next, and then next one. They're putting the delay here because first the blasted, then other. This is the button. This is the spacing is given, and detonators is connecting here. So the single row blasting is activated. Both are connected like such a way. Both are connected here. Go to the and this is the single row pattern of the blasting. I go to the next is a multi blasting pattern. The holes are drilled in several rows. The holes may be staggered or square. After the holes are drilled, blasting may be carried out either by wedge cut pattern or diagonal blasting. So most of the multi blast rows are the patterns are wedge or diagonal patterns. Uh, that I'm showing here the more number of blast multi-row blasting patterns. So this is also multi-row blaster. This is also V-cut pattern of the blaster holes. This stagger pattern. We can be go through the multi-row blaster method, including pattern of drill holes is different. Pattern of multiple row blasting is also different. Okay, this is one of the simplest figure showing different sections, different holes, the sequence of blasting also here clearly mentioned. And then wedge cut pattern. This pattern as shown in the above figure is adopted in the hard and medium hard rocks. So it can wedge cut is pattern is complex exclusive use for the hard and medium hard rock for you go through for the wedge cut pattern because of the more fragmentation required. Otherwise, the simple methods not giving good yield, good fragmentation is also. Delay are fixing from the middle of the end of the shown in the figure. Giving here figure is given. So this is the wedge pattern. See that this is a V-shaped wedge is coming. Oh, sorry, right. So you see here. So one is a delay is maintained here, and another is a two, and also three, and also four, and five, and this is a five, and this is six. But this is a general, but drill holes are in a square in nature. Please try to emphasize on the drills are one, two, three. This is drill is straight in way. Exactly the uniformly they maintain second row also. So this is square pattern. The square pattern, but wedge cut pattern of the blasting. The combination of these two. So these are connected such a way, and firing is connected to detonators and fired it. This is one model of the wedge cut pattern. The center blast hole in the first row blasts first followed by the blast holes connected to the second holes with the delay one, and then it is a sequential order of the delay. A diagonal blasting pattern. This type of blasting pattern is carried out in a benches where the cleavage planes of the rock is parallel to the length of the face. These patterns reduces secondary blasting. The blast holes can be drilled in a square or a staggered pattern. The delays must be planned in such a way that blasting proceeds from one side to the other. It must be ensured that the delays are in proper sequence to avoid any cutoff. This is a diagonal type of pattern is concerned. You can see the figure here, the diagonal pattern. Here, simple the square pattern of the drill holes pattern is there, but they are connecting in the diagonal nature. So one is here, two is here, the three here, and four is here, and five is here, and six here, and seven. This is the eight, this is nine, and this is 10. So this is the one my methodology of diagonal line patterns. The quantity of explosive required per round holds in a estimation only since it is generally practiced by go for trial and error method. So how much quantity required per hole? So generally they go to trial method. This is because of the variation in the physiological property of rock mass. However, the quantity of charge can be calculated by the specific formula is also there. I'm going to explain next slide in the and quantity of charge is required. So Q is a quantity, E equal to specific weight of the that particular explosive, H height depth of hole minus the height of the stemming, pi d square by 4. Pi d square by 4 is the general formula you are using for the quantity required in the for particular hole. This is the general standardized formula. Q is equal to a specific weight of the explosive, H minus stemming, that is almost 3 by 4th will be using for the for purpose, and pi d square by 4. Here d square you are using the d square, not d2, it is a d square uh, for the one. And next, specific consumption of the explosive equal to, what is the mean by specific consumption of explosive equal Q. Q means already you are aware that Q is a quantity required for the charge divided by BSH. What is the B? Burden, spacing, height. Then you get the specific consumption of the explosive. So for a whole, how much explosive is the consumption will be indirectly we will get into the Q by BSH. Q is a specific charge. The specific charge will be to E minus H minus stemming into pi d square by 4. Similarly, Q, where Q by multiplied by with sorry divided by BSH kg per meter cube, the specific consumption of the explosive, where B is the burden, S is the spacing, and H is the height of the charge. Powder factor, what is the mean by powder factor? BSH multiplied by Q. This is called opposite of the specific charge is that is a BSH by Q. That is meter cube per kg. The charge required per a hole is the first calculated considering blast geometry and the powder factor. Then the total charge required can be easily calculatable. So this is a simple calculation of powder factor and specific charge for the. So how much effectively we're utilizing of the explosive, wastage of explosive, more explosive using less yield will be going the uneconomic. So that specific charge, the opposite to the border factor is very essential for the particular FEM calculation purpose. So I hope that you understanding the how to calculating the volume of a particular BASH and the quantity of charge. So quantity charge by BH is called as a specific charge. The opposites are the BSH divided by Q is called the powder factor. Now, the charge required for the blasting a round of holes. The quantity of explosive required per round of the holes is an estimate only, since it is a generally practice to go by the trial and method. This is because of the variation of in the physical. Already, this slide is completed. And go to next slide. So now, this is next. Next, these are blasting tools. What are the blasting tools using the uh, for purpose of blasting activity? The various tools it's required for the purpose. Wooden stemming rod is one of the important item for the stemming of material. If stemming is not properly done, the entire blast material will be, when the weak section is a stemming side, only whole inside side. So their horizontal direction they are not going. They go to the vertical depth. That means coming outside of the hole. So the if good stemming is not there, the problem of fly rock problem in proper fragmentation is a problem we getting. So the stemming tool is important for the powering properly, hardening of the hole closing is important. So wooden stemming rod is one important. Scraper is also you are using. Metallic wire tape with the height weight at the zero end. Single beam torch light is also because of the what is the hole is filled with stemming. Explosive can't be filled with properly or not, or excess or low. So single beam charge torchlight is also important. Pen knife is also very one of the important. Creeper is also important. Electrical exploder, cable for short firing. These are the items were required for the blasting tools. Then charging. The following precautions should be taken. Ensure proper blasting. The drill hole must be checked for the proper depth, water accumulation, and cracks in the holes by means of magnifying glass or a torchlight. Matching the diameter of the explosive, skin to the skin contact of the explosive within the sides of the holes is required because of any gap between the explosive and the walls results in the loss of explosive energy. So these two must we take care while charging is taking. In it confining the explosive energy within the blast hole, and hence the care should be taken to use proper stemming material and to design that proper depth. Selection of safety fuse and boosters. The detonating cord should be carefully selected to reduce the loss of the blasting energy. Cutoff and ejection of the stemming material. The pentaerythrotetronite (PTN) is a cord should be distributed uniformly without the formation of granules. Right choice of delays. Right choice of delays and proper planning of delays. The delays play an important role in orienting the blast and in reducing the secondary blast. Care should be exercised in using millisecond delay, and the delay between the first and last row holes should not be exceeding 1000 milliseconds or 1 second. This is more important. Most of the 1 second will be maintained, not more than the 1 second. So here, I mean, the delay. What is the purpose of delay? Means creating the free face to the and giving the choice to the gap to the next row or next holes. So in such a way that a plan that once the millisecond gap, the remaining material can be released into that direction. So good carbonation expect. Otherwise, the shattering effect is caused. Just the cracks are developed, but good fracture is not expected. So delay is the role is a very important charging is concerned. So delay element, which holds your to put delay, is also the ideological procedure. Okay. Charging is done by dropping one cartridge after the another. So generally SMS is there, direct pipe powering to the hose, but sometimes cartridge bags also using in case of water nature in the hose. The detonating cord should be tight around the priming cartridge with a reef knot, and the cartridge should be lowered slowly into the hole. Sometimes they are powering speedy because of the tidiness. Some workers are not in a idea to how to inserting inside the hole. These also cause misfiring, some not firing procedures. From very recently, we see in the Godavari area, Singran College, 4 members contract labor will be labors. Assassination happened in a dangerous situation. Four members have died at the spot while loading only. So this is a very important while explosives are filling into the holes, particularly cartridges with the knife knot, and the cartridges should be allowed to swallow into the hole. It must be ensured that the cartridge is lowered vertically to enable to safe passage of the to the bottom of the hole. So sometimes the cartridge will be tilted, so the remaining gap will be not filling. So we think that the holes is filled by the one or two bags, but this is also take care. The bag should be going in the verticality. The cartridge, the cartridge must be sealed to enable contact of the exposed holes with the walls of the drill hole. The other cartridges must also be sealed and dropped into the hole after charging. After charging of charging of the whole length of the hole in second primary, dropping ensure avoid the misfires. Hence, two detonating cords are seen to at the mouth of the hole. The charging of the holes is followed by the linking the detonating cords at the mouth of the holes. trunk line. Usually, reef knots are generally used. Uh, the delays are then connected to the trunk line. By connecting the trunk line, detonating cords and connecting the delays. Then, so now these are the procedure of the um, uh, charging procedures of the uh, how take care while explosives are fulfilling. So now I am concluding this particular related parameters. This onwards. Now I am going to recollecting and revise the what we are learned in the these 40 to 50 slides. So particularly you are aware. I hope that you are all are understand and enjoy this topic. The particularly different parameters connecting to drill blast hole. So drill blast holes means making of the holes is a one parameter by the drill, and what pattern you are drilling. That is one of the important. Whether you using the sequential square pattern or stagger pattern. This is one thing. Another thing is that these holes to how you firing is also one other challenge. There is a pattern, single hole or multi hole or a diagonal. So entire pattern design engineer have depending upon the parameters, which parameter, why it is required, different patterns, different drill hole patterns, different firing procedures. So these are the brought into mind while planning of the particular. You go through for geological information is also very important parameters in our hands, and also physico-mechanical properties of the rock, the particular mine rock. These are the when planning itself, you are collecting that information. The what is the physical strength and mechanical strength and compressive strength and what are the fissures or what are the play bedding plane nature. So accordingly, our drill pattern holes are made and also firing also there. So these are the you are brought in mind when the uh, parameters is concerned. And another important charging also the pouring of the bags or inside the holes and stemming is also one of the important. The stemming tool should be used properly. Stemming of the one third of the that hole, two third will be explosive cartridge. The explosive cartridge should be ensure that you have to pour it into the cartridge bags inside the vertical manner. Otherwise, some of the holes will not blasting. The more secondary blasting activities. This leads to the delay of the process. Automatically, the overall mine production will be affected. So I hope these are the parameters we are all are covered in this class. Now I'm going to the future. Some of the simple quiz questions I'm giving here for the purpose of competition examination. In case of the some of students are appearing the ESET examination, some of uh, preparing for the JET junior mining engineering examination, Singapore or other Western Coalfield or other companies, coal-based company or metal-based company. So quizzing is one of the activity that for conducting examination is concerned. So I am giving a model here. The following are the parameters related to the drilling of blast holes. The following are the parameters related to the drilling of blast holes. So what is the following are the parameters related to the drilling of the blast holes means what is the mean by dynamic tensile strength, compressive strength. So most of the all parameters you are using here. So that is also one of the important for bit in for coming. Another second quiz is there. However, considering the pattern of the blasting pattern, this can be classified as follows: single row blasting, multi row blasting, all the above. So simple, I'm giving the one. This type of questions you are aware that for at attempting. I'm giving a simple assignment for you. Write the about different parameters to connect into the drilling of blast holes. Write about this one. Uh, it will help to you practicing purpose. Simple sketch you are using so that you can understand easily what is the drill hole patterns and firing patterns. These both are different. uh, Next, I'm going to give the frequently general question is coming to the explain the different parameter connecting drill holes, blast holes is a common essay type question coming to these type of academic examination purpose. Right now, at glance, I'm going to close this one. Once again, I showing the all the PPTs at glance. You see it. right? So I am now concluding that one. This is the most all slides are your understand. So I wish thee all the best.